Hey guys, it's Kevin and Eric with Ameribraid, and today we're going to talk about how we make our hardened platen. Let's talk about maybe what the ideal platen is.
Just some of the requirements that we set for ourselves, and they kind of developed over time. People's requirements are different based on their application. The set of requirements we came across are what apply to the most people doing high-level work in a broad sense. You can't go down too specific of a road because it just doesn't serve the needs of enough people.
When we first started doing this, we did it a different way, and we'd constantly get feedback saying, like, oh, what if you guys do this or thought of this? That kind of led us to what are people really looking for, not just what's perfect to some people, but what are our majority of the customers telling us?
Yeah, there was a common thread of where the previous designs were falling short. So once you notice that consistent feedback, then that's enough reason to make a change that applies to everybody.
So here's this, and one thing I think we heard a lot of was people wanted it flat.
Yeah. And what does that mean? Everything's got a tolerance. So in the beginning, we thought as long as it wasn't bent, just cutting it out of a flat sheet. We used to cut these out of hot rolled, pickled and oiled sheet. For a lot of applications, that's good enough as far as flatness goes, but we were getting enough feedback from people with higher quality requirements that needed better flatness.
So it's got to be flat. Now, the next thing I think we would hear a lot of is it didn't remain flat.
Yeah.
Even if it was flat when they got it, or it was good enough for them.
Yeah. Even if it was flat enough when they got it, it wouldn't stay that way for long enough.
Yes.
In use.
And that would come from not like a structural pressure of bending this whole plate or anything, but worn away areas from belt. The belt and grit behind the belt causing a divot to where you grind away, where you're grinding, we have the grinding pressure of the belt.
Yeah.
It's a really abrasive application, actually.
Yeah, it was strong enough, even though we used to make it thinner. We made it thicker for some different reasons. But even at 1/4 inch thick when we started, nobody complained about it not being stiff enough. So we had met the stiffness requirement, but just wear resistance was lacking.
And then I think those are the two big things we hear.
Yeah, those are the two big
Stay
things.
flat as long enough, or it wasn't flat when I got it. One thing we did hear a teeny tiny bit when we experimented with some glass is ease of replacement.
For some users to solve the wear resistance problem on their own, they would attach a piece of ceramic glass to the front of the platen. Back when we started, we used to attach the platen with a countersunk screw from the front side of the platen. However, that means when you put a piece of glass on, it covers up the heads of the screws, and there's now no way to take that piece off anymore. It's trapped on.
Yeah. And there's a few things you could do about that, but what everyone was doing was not listening to us, which is fine, and they were going on the forums, because clearly everyone on the internet knows better, and they would get themselves in a pickle and then be upset with us. So,
yeah. Especially when that piece of glass would crack, and now they've got a bunch of cracked glass glued to their platen.
Yeah, that they couldn't get off. So that then became our fault. But we want to add value to people's lives, so that means solving some of their problems. That was what we heard quite a bit. Other requirements I think we put on it that we maybe didn't necessarily hear, that we knew we wanted, was we wanted some precision edges. We knew a lot of guys were grinding on this and did not like raw edges.
The straightness of the edge isn't as high of a requirement as the flatness of the face, but definitely do not want a random edge that you kind of get from raw mill stock. So when you get a piece of bar stock, whether it's cold rolled or hot rolled, you can't really trust the edge to know what it's going to be. It might be okay and it might not. It's just not repeatable.
Yeah, you can't control the radiuses or the angles, or sometimes it's mushroomed out, sometimes it's got a weird taper in. All kinds of stuff happens when they form the raw steel.
Yeah.
The other requirements, kind of holding this finished piece here, is for some of the reasons we just talked about, we knew we wanted tapped holes.
Yeah, so switching from a countersunk hole to a tapped hole solved a couple problems. One, it made it to where if someone still wanted to put on a piece of glass, the screws are now still removable from the back side of the platen. The other thing it does is it allows you to, the platen is not directional. There's not a countersink from just one side. You can flip it over and get double the life out of the platen. It's kind of a double benefit from one decision.
That was a real nice thing we understood. When now you're kind of buying either two platens because you got front and back, and most of the time when someone uses it, they just use one area, usually right here. Well, now you've got almost 4 times if it's symmetrical, true symmetrical.
Yeah.
You've got 4 areas you kind of get to wear away.
Yeah,
so
flip it front, back, and top to bottom.
yeah. Another thing we knew, because of the flatness, we knew, I think people were going to deem flat was either a machine surface or a surface ground surface.
Yes.
Had to be one of those. It couldn't be any sort of raw stock that wasn't going to be flat enough.
So we knew the final step of whatever we went to was going to be machined or surface ground.
Surface ground generally is known as flatter and a superior surface finish if you're doing that. So to try to come up with something that had that was a benefit. So we knew surface ground would probably be best.
One of the things that had to change when we went to tapped holes is we had to make the platen a little thicker. Before, 1/4 inch was thick enough for strength purposes. Having only a 1/4 inch of thread engagement makes it to where your through lengths have to be very precise to not stick out the front of your platen or have too little thread engagement. The margins are just too thin for how much the bolt is sticking into the platen. So we increased the thickness from 1/4 inch up to about 3/8 of an inch. Once it's ground and everything, the thickness varies a little bit, but it's slightly under 3/8.
Even though we knew, okay, this was kind of the end result we wanted with surface finish and some of the features, now you knew you're going to need to be able to make hundreds of these at a time.
Oh yes,
not just one.
That's another large requirement for almost any design decision is how many of these do you have to make and how repeatable is the process need to be and how labor intensive is it going to be and how much do you want it to cost at the end.
So we need to be able to mass produce these hundreds at a time.
We know to solve the wear resistance problem, we knew that the surface needed to be hard. Our knowledge of making things hard is you can either choose a material that can be hardened throughout, or you can case harden it through a process that we know of called carburization, where you start with a mild steel and during the heat treating process you infuse the outer layer with a higher carbon content in a carbon rich environment and essentially create a high carbon steel on the outside. So you have an inexpensive base material, has a shell of high quality, high carbon steel that has a very high hardness and good wear resistance. So in this application, the core has almost no role to play. So there's no point in spending, in our opinion, there's no point in spending any money on exotic materials that add no value to this application.
Because you can get, you know, the exotic, we like using that term, the exotic tool steels that everyone likes to talk about. If you're a blade maker, you know exactly what we're talking about. Those have a lot of qualities that are good for blades, but when it comes to this, it has a lot of good qualities that you just don't need. So do you want to pay for something you don't need is what we thought.
Yeah, we actually experimented with, it was D2.
D2, yeah.
Has a great reputation and everything, but it just drove the cost way up. It made sourcing more difficult. The heat treating was actually, we were having a hard time finding heat treaters who could do the process affordably and keep the parts flat enough.
Yeah.
Speaking of keeping the parts flat throughout the heat treating process, that also goes back to our another benefit of going a little thicker is the thicker parts are more stable during the heat treating.
Again, if you're a blade maker, we still do a lot of blade makers, motorsports guys. If you're a blade maker, you know when you have some thin material, it's a tricky to heat treat it. So
yeah,
same thing applies here.
Adding a little bit of thickness helped with that.
And I think too, we're talking about hardness right now. So we had tool steels, maybe a soft steel, a case hardened. Glass was also an option. You could do some sort of glass platen. Glass is very hard, as you guys know, and that is definitely an option. We looked into it. We actually made some. We got some of the glass pieces made. You use a high temperature glass, like a Pyrex is a trade name, or if I'm saying that correctly, but just a high temperature glass. Yeah. The thing we did not like about that we experienced right away, because we did make a handful of them and help some customers get their hands on them, is it is very fragile. Glass is not known for being tough. Glass is known for being fragile.
I mean, it's relatively tough as far as glass goes.
Yeah.
But it's still too niche for, I would say, the light to medium duty applications. But for someone who just wants to walk up to the machine and shove a piece of steel in as hard as they can, it's not the ideal surface for that.
Yeah.
We saw several people with shattered glass platens.
Yeah, even from those few sent out, we had calls from customers.
Yeah.
So that kind of ruled glass out for us. It wasn't as robust as a nice hard piece of steel might be. So that's what led us to, you know, the choice of for sure metal, and then the choice of tool steel and case hardening. Case hardening was less expensive, still provided all the benefits, easy to get a hold of. So again, making hundreds of them at a time. D2 or exotic tool steels are not only more expensive, they're harder to find. Sometimes you just can't buy what you need.
At least in a timely manner.
Yeah, everyone's got it, but then you're paying more for it and you have to raise your prices, or some guys got it and you got to ship it over somewhere. So it's just everyone carries mild steel. We for sure knew we wanted to case harden and surface grind.
Now, as you might have noticed on our table here, we've got the different stages of creating this final product. Working backwards from having the case hardened platen that's surface ground and ready to ship out, you can see we've got the platen as it comes back from heat treating. And we save the surface grinding for after heat treating, one, for cosmetic reasons, as you can see, but the primary reason is flatness. Even though we send them to the heat treater within spec, and the heat treater does a fantastic job of minimizing warpage, you cannot guarantee that they will be as flat post-heat treat as they were pre-heat treat. So we save the surface grinding for after heat treat. That's the main way that we can guarantee that the parts are as flat as they need to be. Knowing that, we had to decide condition we were going to deliver blanks to the heat treater in. One option that we strongly considered was delivering a laser cut blank out of sheet stock. That is super affordable. Edge quality is good enough for this application. Your edges are straight and square enough to meet our requirements.
Yeah.
So it solved those problems. The only concern we had with that is how flat is it to begin with? Because case hardening only goes into the material a certain depth based on how long you leave it in the oven. And we go 30 thousandths deep. The piece needs to come out of heat treat within that tolerance of flatness so that by the time you're done grinding it flat, you haven't removed that 30 thousandths of case hardening and back to soft steel. So you have to deliver a pretty flat blank to begin with.
Although you could perhaps go thicker with the case hardening as well, even though that might cost more, or definitely will cost more. Now you have a lot of material to get rid of. When you send something out to a grinder, they want to remove under 5 thousandths of an inch. They do not want to remove 15 or 20 thou. They just those guys are they freak out when you tell them they have to remove 20 thou. They are not used to that.
Yeah,
so
they're
then
doing precision work. They're not trying to do hogging there.
Yeah, they consider that hogging. Yeah. So then you could mill it, but we knew we wanted something roughly Rockwell C60. Milling a Rockwell C60, although possible, when we're trying to do hundreds at a time, might be a little tricky to have it repeatable at the cost that we want. Yeah. So that was a problem with perhaps milling a finished product at Rockwell C60.
That kind of moved us away from laser cutting just because we didn't know if we could keep it flat enough out of sheet stock to keep the grinding minimal.
Yeah, I mean, we knew you couldn't. When you get sheet stock from every different place, they have giant machines. All the sheet stock comes off of a coil. They unroll it. They take all that stress and they kind of bend the sheet backwards and then bend it back to flat again. But it's a very fast process that is not meant to be that precision. So although your sheet as a whole might be flat, when you laser cut the parts out of it, you'll see them start lifting up and warping. There's a bunch of internal stresses in that sheet. We can actually hopefully show you guys that someday. We have some cool context to what's called uncoiling. But all the sheet stock you buy is uncoiled.
Even really thick stuff. You might think just thin stuff comes in coils, but
up to 3/4 of an inch.
Yeah, it comes in coils that they flatten out. And we already had experience with how not flat sheet stock was with even our Platen chassis, which are cut out of 3/8, and you just can't count on them being
Those have
precise.
to be post-machine.
Yeah, we have to post-machine the surfaces on those.
And again, we already were doing the 1/4 inch laser cut platen. That was our original platen. And that was not considered straight enough by quite a few customers. So that's what sent us on the quest of trying to make a superior platen.
Yeah, it was a good place for us to start. And that's why a lot of people still make platens that way.
It's very affordable.
Yeah.
It's hard to justify going this, but when you hear it from enough people, you're like, okay, we got to figure it out.
Yeah. Knowing that for now didn't want to try that route.
Yeah.
We decided to deliver a machined blank to the heat treater so that you're starting off a known flatness, and if you're going on the machine, you can drill and tap the holes that we decided we needed anyways.
Yeah, we can put a real nice edge chamfer. It's not much, but it's just enough where you don't cut yourself. You don't have this crazy razor sharp edge. Yeah. And we can also mill 360 around this. So every surface of this blank that gets sent to the heat treater is milled.
Yeah.
So
there's no surface on the blank that hasn't been touched by the machine.
we have complete control of what that looks like.
To get to this point, if you know you're going on the machine anyways, it allows you to make the next decision, which is kind of what material is getting fed into the machine. So basically the two options we saw were either hot rolled or cold rolled were the two big choices.
And a tiny bit back to what we talked about a second ago, this was another factor for tool steels. If you are going to use a tool steel and then you want to machine it away, that can be a lot slower on the machines and cost a lot more money in high-end tooling. You're not nearly going to get the tool life and stuff out of it, so it won't be as repeatable. If you're doing machining tool steels, you might get 50 parts out of an end mill or something. As here, you know, we might get 200. So it's a lot more repeatable, easier for our guys to run it.
Choosing between hot rolled and cold rolled, I remember we called around a few places just to check availability. The hot rolled was definitely a lot more available and a lot more affordable. Usually the downside of hot rolled is that you have a mill scale to deal with, but we already determined ahead of time that we're going to be machining all faces of this before delivering it to the heat treater. So the mill scale just wasn't a problem that we had to concern ourselves with. So it wasn't worth going with cold rolled because the downsides didn't apply. We'll show you a little bit of the process, how we take this raw piece that we saw cut out of bar stock. We machine the first side of it, what we call op 1. Which leaves this flange to deal with, and then it gets flipped over in the machine, and then the second side gets finished, and then it goes out to heat treat.
Then it comes back and then it goes out to a surface grinder. Heat treating and surface grinding are both pretty specialized processes, so we can not do that in-house. You'll see we found some pretty good people that take care of that. So let's see how it's made.
So now we're back at the Ameribraid machine shop and we'll start showing you the actual process of getting these things made. Most of our parts start out in the material yard. We go through quite a few of these things. So I don't know, how many bars would you say we go through at a time?
I think we usually get 20 or 30 bars and order that whenever we need to, maybe
those
2 or 3 times a week or something.
Those 12-foot sticks?
20 footers.
20-foot
20
sticks.
footers, yeah. Here we only got 1 stack left. Usually there'll be 4 or 5 stacks like this. So we'll grab the forklift and get this stuff cut up.
First step is to get the stuff loaded onto the saw and get it all prepped for the machine. Clean up cut.
So part of that problem about choosing the correct material that you can use to make stuff in high quantities, not just onesie twosies, you have to choose something that's readily available, preferably inexpensive. So we're using a mild steel. This is a hot rolled mild steel. We had played around with cold rolled mild steel. Sometimes cold rolled has a few problems when you mill it. It might do some weird stuff because of some of the internal stresses that it gets when it goes through the cold rolling process. Another problem is cold rolling is a little bit less available over a hot rolled material. And when you are building this into your system, you need to be able to call and get it. And we did run into a problem where the cold rolled was not available. So we ended up switching back to a hot rolled. It's a little less expensive. We worked through those challenges or problems with the benefit of availability and a little bit more stable after the milling process. So Eric's getting the saw set up. This is a automated bandsaw. So you put all the material in there. We're really kind of fortunate. Again, when you're dealing with high quantities, you can't cut 1 bar at a time. We will usually cut 4 to 8 bars at a time. We have about a 12-inch width that we can cut at once. This we set up, we tell it the length we want, and we could do all kinds of stuff on the control. You dial it all in, and then you just let it start cutting and walk away, and it will cut up all of your material again, when you're making stuff in quantity, you can't worry about one cut. You need to just be able to walk away from it. So, and as you'll see on this saw, you know, we are getting into the quantities where you worry about a lot. We have different blades for every material we cut. We cut a lot of steel, we cut a lot of aluminum, and those require different blades to really optimize the process. So the first cut is just to get a clean cut. It's called the cleanup cut. And then now we are getting into our actual work pieces. You can see the machine gripping, cutting, re-gripping.
So this is what it looks like when it comes off the saw. One of the downsides of using hot rolled that you have to deal with is the mill scale. So that gets taken care of at the next step of the process where we face mill these. We wouldn't want to send it out for heat treat with the mill scale still on there. First of all, it's not very flat and it might be a lot of work to clean up in later stages. So we send it to heat treat with a preemptive surfacing that gets you down to good raw steel.
We have our fixture, which is holding two parts. So we'll hold two parts, which are raw, which is op 1. So this is where our raw stock goes. And then once that's finished, that is the op 1 finished. Those will come over and go here and go to the op 2 position, which will then finish the part. So 2 of op 1, 2 of op 2. Every time this machine runs a cycle, you will have 2 finished parts. And we have these special little clamps that come down and clamp it in. You have to design and manufacture special fixtures for all of this. It's real common. You'll see a lot of guys do what's called vice work. You could just hold these parts in vices. So we have to make specialty fixtures. So this is a really special machine. We do such high quantity of these that we invested in this special type of machine. This is called a pallet changer. This is by a company called Brother, if that logo looks familiar. This is the same company that makes sewing machines and printers. And side little interesting fact, the #1 purchaser of CNC machines in the world is Apple Computers. And they have some crazy amount, I forget the number, but it's like 5 or 25,000 of these machines. These are some of the fastest, most efficient CNC machines in the world. So we got one to make these parts. What's so special about this machine, with it being a pallet changer, I can be in here switching parts and doing stuff while the machine is running. Notice this is different from other CNC machines. You don't see any tools or anything usually doing the work right here on a CNC machine. So I have a door, I have a safe area to swap parts while the machine is running. When these parts are ready to go, I simply close the door and I let the machine know that it is ready to run this pallet when it's ready. As you see with what we were talking about with this machine, it's kind of in this compartment right here, doing all of the work to the work pieces or the raw stock. And over here in this other compartment is being here changing parts now. So I'm free to open doors and change parts. This is really a big deal in manufacturing. That might take you from 40% spindle utilization all the way up to 75, maybe even 80% spindle utilization.
Once we have a batch of about a couple hundred of these at a time, we send them out to get case hardened. We are lucky enough to go visit the guys at High Speed Steel Treating, and they're going to show us their case hardening process to bring this mild steel up to a Rockwell C60 hardness to bring up the wear resistance. So I'm real excited to learn about this process. Let's go see it. All right, we got back those parts that we brought down to the heat treaters. They've got them all done and case hardened. Let's check out what they look like when they come back. These things look pretty cool, but unfortunately they're just not as flat as they were before we sent them out for heat treating. So we've got a friend of ours who actually started doing the surface grinding for us. It was a good way for us to work with a friend and have him help us out with the machine he's got. He's got a nice traditional surface grinder, so he brings these things into tolerance for us, and we're actually gonna go check out his shop as well. So let's go see where these things get the last leg of their journey completed. So we're here over at Mark Wayne's shop. He's one of our buddies. We actually met him, if you know a little bit of mine and Kevin's story. We started our journey where we met each other at our day job, an aerospace company, and that's where we met Mark too. So he used to help us out late nights when we were getting started, helping us program the lathes and everything, and things have changed over the years.
Yeah, things have changed a little bit. Inherited a couple of machines. I've got a 2-axis CNC mill and a nice surface grinder here that I help the boys out with grinding these platens.
Do you regret taking on the work?
No,
it's not.
No, it's not too bad. It's nice to be able to work from home and you know, keep you guys afloat and keep everything moving through.
Do you have dreams about grinding platens yet?
Muscle memory.
Yeah.
Muscle memory,
Well,
which is good and bad.
Love to see the process.
All right.
You do when you get a box from us.
That sounds good. Let's do that. I've already grabbed this one out, and I'll just show you here. What I'm gonna do is I go ahead and I grab one out, make sure the plate's clean. And after the heat treaters, there tends to be a little slight bit of a warpage, and you can hear that ticking. So what I do is I put the bevel side up to the grinding wheel. So we'll start with that. But first and foremost, anytime you start up a surface grinder, we need to dress the wheel. Doesn't take much, 3/4 thousandths just to get a nice clean smooth surface all the way across. Come down on that nice and slow. And I'm just listening for just a faint sound of the diamond hitting the wheel right there.
How often will you redress it as you're working?
I can usually go 4 to 5 platens each side, front to back, before I'm coming back and dressing it. So I'm just listening for it to go, make sure it's all the way across, because that's a 1-inch wide wheel. One last pass, and we're good to go.
How much does one of those cost?
They're not bad, actually. It's about 250 bucks by the time it's shipped here. So this is just a magnetic chuck. So now we're going to go ahead and spark off and see where we're at. As you can see, I'm coming down nice and slow because these platens are nice and hard. You always want to make sure your magnet chuck is on. So I'm just starting to kiss right there, and it's got a set mark right there. I'm going to go ahead and knock it down another 1.5 thou. And as you can see, I'm just taking off all the high spots. Now, as you can see, when they're machined flat, they look flat. You can actually see what the heat treating process has done to these things.
You can tell the difference between grinding one of these hard and grinding some mild steel.
Absolutely, 100%. 100%.
You can just tell by looking at the sparks too.
Yes.
These things have a lot higher carbon content than when they started. Is that pretty warm?
It's actually not, because that's a fresh dress on the wheel, so the pores aren't loaded up in the wheel, so it doesn't transfer as much heat. That's the other reason I try and redress every 4 to 5. So now this side, we know where we're at, so I'm going to come down 1.5 thou because I know I'm already flat. Good. 100% cleanup, top to bottom. Both sides, and now we'll check it on the surface plate.
What increments are that indicator?
This indicator is 5/10, and this part is actually bowed, and I'll show you how we're going to fix that. That's a 3 thou shim, and that's a 4th thou shim. So 4th thou goes under that, no problem. Take that bow out of the top. So I'm not going to touch my, I'm not going to bring my wheel down anymore. So as you can see,
way heavier cut in the middle.
so now we're within 2. We're flat within 2 thousandths across roughly 8 inches long in between your bolt holes.
And we could chase that more, but I don't even know what tolerance we call out, but it's one of those things where, like I said, when we got hundreds of these things to do, you have to pick a number that's realistic and how much do you want to,
Correct. So as you can
you want to spend making it
as you
good
can
enough.
see, some of them, one shot, flip it, one shot, you're flat. Other ones, you get them off, they're warped. Could be because of heat treat. There's no rhyme or reason to it. It's just the way it goes. But I'd say 3/4 of them, you have to go back and retouch.
The way we look at it is it's a belt running over it, and the belt thickness variation is what we've noticed is at least 10 thou on belts. So
On your variation? Yeah.
yeah, so at a certain point, it's not worth. You want to chase as much perfection as you can, but
Yeah.
I think we call out 5 thou on these. I'll have to double check.
That sounds
I'll
about
put that
right.
in without verifying.
I usually go by the tap test. You know, visually you can see. Sometimes they're way warped or I have to shim each side of it and kiss and kiss and kiss and continue to. So we got pre, heat treated, and ground. Okay, so pre. Okay, so now this is heat treated. Let's make sure everything's clean. There's that rock again. Okay, so
magnitude isn't much different, but it's a very noticeable bow, whereas this one just had a low spot in the corner. This one is
right. Now if you look, if we're just on this edge, there's only 5 thou bow, but look what happens when we get over here.
Total deviation can be somewhere around 10 there.
See, now you guys have seen how we make just one small component, literally just a square of steel. Hopefully that gives a little insight to how we actually make some of the stuff.
If you want to see more of what goes into making our machines, hit the subscribe button. Also, you can follow along day to day with our daily content on Instagram. Follow us at Ameribraid. Go to the website if you want to pick up a replacement platen for your machine. And check out everything else Ameribraid has to offer at ameribraid.com.
And if you want to tell us how we did everything wrong, just leave a comment.